Okay, for this second part here, so the law's caught up with the boys and are waiting downriver on the other side. So if we sit here and draw our picture, there we've got our cop car waiting downriver. So, at what heading? So we want to know the direction. Should the boys point their boat so that they land safely and directly across the river? So we go to draw our picture for this. Remember, we're still you can still only go 25 meters per second regardless of which direction that it's pointing. We have our river trying to push us 11 meters per second to the east, and then so now we have a new angle here. So when we go back to our space to work, so we have 25 and we have 11 now. So we've rearranged this. So to figure out our angle, we're going to use sine is opposite over hypotenuse. Let me zoom in so you guys can actually see this a little better. There we go. So sine of the angle equals, since we're figuring out this angle, opposite is 11 over 25. And since we're trying to find the angle, it needs to be the inverse of this. So what you end up getting should be right around 26 degrees. And then we are west of north. So there is our angle for that. So now we want to know how long it will take for them to cross at this heading. So just like before, let me draw my triangle here. So we know 25, we know 11, we know our angle is 26. So what we need to figure out first off is we need to figure out this velocity, because this is the speed the boat's actually going to get pushed in the northern direction. And we know the distance that they will travel going north. So to start off with, a squared plus b squared equals c squared. So a squared plus b squared equals c. So again, this is the formula that we're using. No, this isn't the formula we're using. I'm sorry. We need to rearrange this so it's basically, I'll just arbitrarily pick that it's a equals. So a equals, we need to subtract b to both sides, and then take the square root of that. So when we look at it, a is going to equal 25 squared minus 11 squared. Then you'll take the square root of the whole thing. So when we look at this, we get, oops, I added it instead of subtracted, 22.45 meters per second. So now we know their speed going directly north, and then again how long will it take, so we're using the time equals distance over velocity. Our distance is 350 meters. That hasn't changed. Okay, so we're taking our distance, which is 350 meters, divided by our velocity, which is the 22.45 meters per second. And so we should get somewhere right around 16 seconds.